Yeah, welcome back to AWS DevOps Lokesh Tech YouTube channel. Today we are discussing about you know API groups and authentication and RBAC role-based access control. So I'll share my screen. Yeah, is it visible?
Yes, sir.
So we are going to discuss about API groups. Okay, what are the groups are there? What is the meaning of group at all? Just give me 1 second. This guide message. Okay. Okay. So authentication and access controls. Before this authentication, we'll discuss about this API groups. What is exactly group and all. So yeah, what is exactly Kubernetes API? Hmm? We have learned about the Kubernetes Kube API server. So whatever operations we have had done before so far, like so with the cluster we have been interacting with the API server way or other either through kube control utility or etc. So we want to check the version. We can able to access the API server at the master node address followed by the port so and so XYZ 6443, this one. Okay, by default. Okay, and the API version is P1. So that
V1.
this is default port 6443. Okay, so the version and the API Kubernetes API is grouped into multiple such groups based on their purpose, such as one for API, one for health and metrics, logs, etc. etc. See, I mentioned here. Okay, so yeah, metrics, health, version, API, APIs, logs. Okay, these categories. Okay, etc. So the version API is for viewing the version of the cluster. As we just saw, the metrics and health API are used for it's used to monitor the health of the cluster. Logs are used for integrating with the third party logging applications. Okay, we'll focus we in this actually we will focus on API responsible for the cluster functionality. Okay, these APIs are categorized into two. Okay, core groups. Okay, one is um, named as group. Okay, API groups. The core group is where all the core functionality exist, such as namespaces, pods, replica controls, okay, and events, points, nodes, endpoints. 1 second, I will open this. Yeah, bindings, PVC, config maps, secrets, services, etc. Like this. Okay. The named groups API are more organized, and going forward, all the newer features are going to be made available through these named groups. Okay. So it has groups under the apps extensions. Okay. So in this apps extensions networking, okay, storage, authentications, Okay, certificates, etc. So all this. Hmm? So yeah, we are just going not that much deep, just for a knowledge purpose. So you have to know all these things. Okay, so here I've shown just a few within apps. This is version 1. Deployment to replica sets, stateful sets, these are all comes under one group which is called as resource. Okay, so and the networking, network policies, this is one group. eh? Next, Kubernetes certificates, we have seen last time certificates related, right? That is certificate signing request. So you have seen that, right? Object.
Yes, sir.
Correct. So each resources in this has a set of actions associated with them, things that you can do with these resources, such as list deployments, get information about one of these deployments, create deployment, delete deployment, update deployment. So list get to create all this. But these are this list. eh, this group is called verb. Okay. So access your API server at port 6443 is default without any path. Okay, and it will list it will list you the available API groups, and then within the named API groups it returns all the supported resources groups as just a quick note, like this. Okay, localhost, if it is localhost 6443 APS, like this. Okay, just to keep in mind, that's it. It's not, whenever it is required, will you can go and analysis, do more analysis on this. Okay. Okay, so you have authenticate by passing the certificate file, like this. For Cube API server. So and Cube proxy, Cube control proxy, both are not same. Okay, so Cube control proxy command
Yes.
launches says proxy service locally at port 81 and uses credentials certificates from your kubeconfig file to access the cluster. So you don't have to specify those in the cluster command. Now you can access the kube control proxy service at port 81. Okay, understood. So and the proxy will use credentials from
Yes.
kubeconfig file to forward your request kube API server. So kube proxy and kubectl kube control proxy is not same. That means, okay, we are not going too much deep dive, just we are just going through. Okay, so we discussed about kube proxy in much more detail later, after, maybe if we get chance. So whereas kube control proxy is an http proxy service created by the kube control utility to access kube API server. So so all resources in Kubernetes are grouped into different API groups, like this. Okay, API groups, apps, so extensions, networking,
Yes,
storage,
sir.
authentication, certificates. So these we can make it as a group, API group. Okay, and named API group. Under the named API group, you have one for each under this API group. This, like this. Okay, you have different resources. Version 1, so deployments, replica sets, stateful sets, all. So you have different resources like this, and each resources has set of associated actions like this verbs. So this is resources group. Under this set of actions like associated actions known as verbs. So that's it about API groups. Now we are talking about authentication. So we have seen how someone can gain access to cluster. So we saw different ways to some that human or machines can get access to the cluster. Okay, once they gain access, what can they do? Hmm? What That's what they can do. Authentication defines. Then authentication, they need authentication. So admin need authentication, developer need authentication. If it is bots also have authentication. Okay, as an administrator, as an administrator of the cluster, for example, if it administrator of the for the cluster, so as a administrator we were able to perform all the sorts of operations in it, such as viewing various objects like pods, nodes, deployments, creating or deleting objects, such as adding and deleting pods or even nodes. Okay, in the cluster, as admin we are able to perform any apps operation. As admin have all the privileges, correct? Right. So but soon we will have
Yes, sir.
other accessing so cluster as well, such as other administrator, developers, testers, or other applications like monitoring applications or continuous delivery applications like Jenkins, etc. So why all these authentication, man? Because everyone cannot able to access, correct? For example, cluster. Um, for example, if in this master node, okay, in the master node, maybe if it is master node, if it is this is master node and this is worker node. Okay, so developers will be there, testers will be there, okay, administrator will be there. Okay, so different roles will be there. So those everybody cannot have access for the master node, correct? So admin can have access with the master and worker node, correct? Developers, whatever access we need we will give, correct? So like this, whatever authentication they need, so those authentication we will give. So we will creating accounts for them to access the cluster by creating username and passwords or tokens or signed TLS certificates or service accounts, as we saw in previous sessions classes, right? So we can do that. So for example, if you don't want to, if you don't want developers to have access to modify our cluster or configuration, like adding or deleting nodes or the storage or networking configurations, which allow them to view but not modify, just to only they want to see, so view access we will give. We don't, we will restrict them for the modification purpose, correct? The
Yes,
same,
sir.
yeah, the same goes with the service accounts as well. We only want to provide external application the minimum level of access perform its required operations. Okay, so when we share our cluster between different organizations or teams, logically partitioning it using namespaces, actually we want to restrict the access to the users to their namespaces alone. So there where that's where authentication will help you. Within the cluster there are different authorization mechanisms supposed by the Kubernetes, such as node authorization, a- attribute based authentication, role based authentication, webhook. These are different, I'm telling guys. Node authentication, attribute based authentication, role based, RBAC I told, right? Role based, based on their roles will give authentications. And also webhook, there are different mechanisms. Okay, this is not one way to give the access, you understood? Okay,
Yes, sir.
So these requests are handled by a special authorizer known as the node authorizer. In the earlier sessions, when we discussed about certificates, we have discussed that kubelets should be a part of the system node group, and we have named prefixed system node. So any request coming from the user with the name system, okay, so out of the part of the system nodes groups is authorized by the node authorizer, and the granted these privileges required to kubelet. Okay, so just let's talk about. Mhm. So that is the way you pass the file into API server. Similarly, we create the policy definition file or each group in this file. Okay, that's fine. So now every time you need to add or make a change in security, so you must edit the policy file manually. You restart the Cube API server, right? So as such, the attributes based access control configuration are default to manage. Okay, so let's talk about role based access controls. Okay, so this right, ABAC, attributes based authentication. Attributes based authentication is like this: if developer user 1, user 2, users, so securities, so we have, so they can view the pods, create pods, delete pods. So okay, only for view access. Okay, irrespective of namespaces, so we can give attribute based access controls, right? So what is role based access controls? Hmm? Next to crawl based access controls, make these such easier with role based access controls. Instead of directly associating a user or a group with a set of permissions, we define a role in the developer. Okay, for example, there is an organization. In these organizations, managers will be there, admins will be there, okay, or HR people will be there, account people will be there, okay, and normal, like other employees, others people will be there, correct? For example, if there is a general scenario, I am telling what are role based, I am telling. Okay, not about, it's not related to RBAC, just for general scenario. For example, if there is an application, okay, it is super admin. For example, this is super admin. Okay, so all application related main whatever changes to be done, that will be replicable in the front end side in the application. So this is back end, this is super admin, this is admin, for example. So application related, actually by using backend we can connect these two, correct? So in the super admin, for example, images need to change, it will change and it will replicable in the outside application, correct? So videos, for example, if there is a videos in that application web service, for example web server, okay, this is backend. This backend is there before you see the user graphical interface. There are big structure, okay, that is super admin will be there, admin will be there, backend will be there, okay. For example, the data will be the data of the application, database related data will be there, okay. So all content related content will be there. These maybe if they want to change, yeah, you can change. Super admin can have access and privileges he can able to change all these things, because he know that he whenever it is required, and if there is any problem he will take care. But manager cannot access, admin cannot access, HR, accounts, other people no need to access the super admin, right? Administrative. Why? Because why these guys no need to change? Because if there is any change, it will be replicable on the application. So this application is using by user, right? This will impact on the application. So that is the reason we'll create the roles. Okay, manager will create some roles. We will give access for the particular roles policies. Okay, so if they want view access, for example view, so they can able to see only. Okay, they can't modify the application. You understood,
Yes, sir.
right? That is how we create just a role with the set of permissions required for the developers. Then we associate all the developers to the role. So simple, we are creating the roles and we are associating. In IAM roles we have seen in AWS, right? Same way, concept is same. Similarly, create a role for
Yes, sir.
security users, correct? So similarly we can create a role for the security users with the right set of the permissions required for them. Then associate that to user, to the that role. So whenever a change need to be made to users access, so we simply modify the role and it reflects on the developers immediately. Role based access control provides a more standard approach to managing the access within the Kubernetes cluster. You understood? So we will look all these access controls in much more details next upcoming uh, classes. Okay. So all the authorization mechanisms say that you want to manage authorization externally and not through the build mechanisms that we just discussed. Okay. For example, open policy agent is a third party tool. Okay. One policy is there, open policy. Will this in practical? This one, you see this? This one, open policy agent. Okay. This open policy is a third party tool that helps with the admission control and authorization. You can have Kubernetes make an API call to the open policy agent with information about the user and his access requirements. Okay, you can see. Okay, based on the response. You understood what open policy will do? What open policy will do is, open policy agent is a third party tool. Okay, it will helps with the admission control and authorization. You can have
Yes, sir.
Kubernetes makes an API call to the open policy with the information about user and his access requirements. Okay, so open policy agent decides if the user should be permitted or not. So open policy will be the, so it will decides. Okay, so based on that response, user is granted the access. So this is the decider, decision maker. Okay, so user needed access or not, so this will decide. So where you do the configuration these meds. So now there are two more modes in addition that we just saw. Always allow and always deny. As name states, always allows all requests without permitting performing any authorization checks. Always denies all requests. So that comes under policies. So where do you configure these modes? So which of them are active by default? Can you have more than one at a time? How does authorization works? If you do have multiple configured, the modes are set using the authorization mode option, that is called as Cube API server. If you don't want to specify this option, it is set to always allow by default. You may provide comma separated list, you know that, right? CSV file. Okay,
Yes, sir.
multiple modes that you wish to use. In this case, I want to set it to node, RBACs and webhooks. Okay, so when you have multiple nodes to configure, a request is authorized using each one in order. It is specified. Okay, authorization mode like this, right? So this, so default man always allow, node or a back or back, webhook always deny, always allow. So this will be, so the made operations can be defined by the Cube API server. So all this, okay. Once we deep dive into this, you can understand, because you have to make, you are new, right? So you need to do more practice on these things. This is very big ocean. Okay, so when user sends a list, so when you user sends node authorizer and node authorizer, first when user sends a, first handled by the node authorizer. Whenever user sends request, node will authorize. Okay, it handles node request, so it denies the request if they don't want. It is forward to the next one chain, this one, else this one, like this. So this is row based access control module. Okay, so once its text or grants user permission authorized complete, and it's given to the access to the requested object. So every time module denies a request, it goes to the next one chain. So actually, as soon as module approves the request, no more checks are done, and user is granted to the permission. Okay, so RBACs, I hope you understood or not. Let me try to. Okay, I'll try to rewind. So again, role based access control is will give authorization authentications to the user based on their roles and their uh, importance. Okay, so we do that by creating the role object. Okay, so we create role definition file with the API version set RBAC authentication, so and so version 1, and kind set to the role. Okay, so if you see this, you can understand. One second, see this, you understood earlier. If you see, API version is like v1 and apps slash v1, right? You see this is as a new, right? You understood? Correct.
Yes, sir.
RBAC dot authentication dot cube k8s dot io v1. So this will be the API version 1. Okay, this is API version. Correct. So we name the role developer, as we are creating this role as developers. Then we specify the rules. Okay. So each rule has these sections. Okay. API groups, resources and verbs, the same things that we talked about previous lecture, right? And a previous lecture in the sense just before previous, what I can say then, just before earlier. So you can so you specify the groups names and resources that we want to give the developers access to the pods. So we can write API version RBAC dot authentication dot Kubernetes. This is very most important. Otherwise, it won't recognize. Okay. Kind is role, metadata, name is developer. Okay. Rules. How we are giving rules? See this. You try to understand API groups. It indicates the core API group. Okay. Resources pods. So get to, list to, update to, delete to, create. Verbs. Verbs I have shown you, right? Previous what I can say here. This one.
Yes, sir.
Correct? Earlier I can say, I can mention. Okay. So resources what? API groups. Resources what? Config map. Verbs create. Okay. So like this. You can add multiple rules for the single role, like create role and cube control, create role command, something like this. Okay. So this is other one. If you see API version rbac.authentication.kubernetes.io slash v1. So kind role binding, metadata, dev user developing binding. Okay, all this is different. Okay, so how? So RBAC, by using RBAC, a developer can view the pods, create the pods, delete pods, and create config maps for developers. So namespace we can give as default. So by using this, you can say, you can understand. Try to see this. Just try to observe. Okay. So what is exactly role binding? You understood? So this kind of role binding, it has two sections. Subject is where the specify the user details. Okay, role binding,
Yes, sir.
user details, user dev hyphen user. So these details you understood. Both try to compare these two. Okay, the role
Yes, sir.
reference section is just here, uh, where we can provide details of the role we created. Create the role binding using the cube control create command. This one. Okay, so you have to do this and this both, right? So next, here, one second. uh, Namespaces. Okay, so namespaces is actually default. Okay, so here, so default namespaces it will take if you don't mention. Okay, if you want to limit development users access within a different namespace. Okay, then specify the namespace within the metadata of the definition file while creating them. You understood this point? If you want to
Yes, sir.
limit the developers users access within the default namespace, then you specify namespaces within the metadata of the definition file. Okay,
Yes, sir.
while creating them. Okay, so to view the created roles, you run the command cube control get roles command to list role bindings. Maybe if you don't understand all these things, guys, maybe next, while we are creating all these things, you can maybe try to understand better, I think so. Okay, so these are all commands. Kubectl get roles, kubectl get to role bindings, uh, to describe it, kubectl describe role developer, like this. You understood? Okay, so like this you will
Yes,
get,
sir.
you can able to see. So you can able to see like this. Kubectl get roles in the sense name, age, you will get it. Kubectl get role bindings, you will get, you can see the name of the binding and this time. Kubectl describe, if you see, if you describe, you can able to describe like this. Okay, correct. So yeah, you can, if you want to describe role bindings, you can describe like this. Okay. So development user has access to creating part through. So you can also specify the namespace in the command like this. Okay, you can note this like this. If you want, you can mention like this. This is just for example. Yes, namespace is there right for you. You can mention location namespace like that. So what I'm trying to say, you can also specify
Yes,
namespace in the command in while running the command. So dev user does not have permission to create pod, test, and namespace. Okay. So resources names we just saw how you can provide the access users resources like pods and namespaces. You can go just to one level. You can see here. So allow to access specify resources alone. Example, this example is there as. So you see this resources name we just saw how we can provide. So in this you can see metadata name roles so groups resources verbs. So resources we can mention pods, right? So
yes, sir.
for example resources names, for example blue, developer orange, purple, green. So this different departments resources, different resources you can mention like this: API version, kind, role, metadata, developer. Okay, so developer whatever it is there, just this is for example. Rules, API group, resource, pods. Okay, names don't mind. Okay, whatever name if you want you can keep your names. Verbs we can mention get to, create, or update, to delete, you can mention all these things. Resource names blue, orange, this is just name guys. In place of this blue and orange you might have your own resource names. Okay, that is for example. Okay, so pods we can restrict access blue and orange pod alone by adding resources names, field the role. Okay, well, so I hope, so while we are creating you can get more clear understanding guys. So I hope at least at
Sorry,
least
sir,
you
your
try
voice
to,
is breaking.
okay, so at least you try to
Yes, sir.
understand the concept, right? So this is what the document I had.
Yes, sir.
So along with this document we will take more examples while we are creating the RBACs, role based access controls. While we are doing this you can understand clearly what is exactly going on uh, background by using RBACs. Okay, instead of discussing all these things, if you go practical better you can understand. So next session then definitely we will see more examples by using ChatGPT even. So we'll see how we can create the RBACs, role based access controls, and also role bindings. So what is the relationship between role bindings and roles? So what are, how can we create, how to use it by using role based access controls? But you can understand the concept, right? In general
Yes, sir.
scenario. So not in Kubernetes, in generally.
Yeah. Yes, sir.
So can you please let me know what exactly you understood small in description in short.
Like a role based instance, we have seen in AWS also, like
Correct.
IAM roles.
Hmm.
We specify specific roles for a specific kind, like pods,
Hmm.
namespaces,
Hmm.
like for developers, for separate separate needs. We will create separate roles based on the needs.
Okay. So actually, why we need to create the roles? So why can't we use without roles?
Like for authentication, everyone should not have every access. I think,
Mm.
sir.
Yeah.
Each role need a specific authentication type.
See, in this actually general scenario, you and me is using only for one single user's purpose we are using. But in the organization level, so in organization, lot of departments will be there. Okay. So those departments, so all people cannot have all access. Admin can able to have all the authentications, all access, all permissions, but everyone cannot come and touch everything, right? If something happens, business comes down.
Yes,
Correct. So developers will be there,
yes, sir.
testers will be there, okay, administrators will be there, okay. So these comes under testers cannot touch the development cannot touch the test, something like this. For example, developers cannot touch this access all these things, okay, roles, okay. So they can't use everything. So everyone has their own certain level, okay. So limited access. So whenever they want, they can able to, if for example, if the developer is there, the developer only want to see what is exactly it is if you want, they want only, for example, they want to see only view. So we will give only view access. Why we will give, while we give this modify access, correct. If they do, if they done some changes
Yes, sir.
that will impact others, correct. So this is completely
Yes,
waste
sir.
of time and this troubleshooting waste of time. So that's why very much strict about all these permissions. Okay. For example, if I am as developer, for example, if I am as a working as a DevOps engineer, I have entire application. For suppose I don't know much about this development. I went through the development code and did something without telling anybody. I just kept like this. What will happen? This will impact the application. Correct. Correct.
Yes, sir.
So uh, me as a admin or me as a DevOps, so no need to give the access to the modification of the code, correct. So for that only view
Yes, sir.
access. For example, if you are a really good experience with the checking the code and verify the code, that's fine. But for example, in that case, I can give you access. If you want to verify the code, you can able to verify the code. For example, if I give the entire access, what will happen if you do with a mistake? That will impact on the application, impact on the business, impact on the users. So that is the main cause where we kept the all these users and policies. So we have to make separate all together. So from the developers to tester, tester to developer, administrator to developer, administrator to tester, all these things. Admin is the main. Actually admin can give the access so and so particular related roles and permissions whenever these guys needed or not. So they will decide. So that will be controlled by using RBACs. Based on their roles, access will give the access, correct. That is a overall
Yes,
concept.
sir.
That is overall concept. Try to understand first generally, then after we will go deep dive into this Kubernetes, okay. So next session,
Yeah, sure, sir.
get ready with the Kubernetes clusters. Let's do that, okay. RBACs, how we have to create
Will you
role.
message, sir, in this next session?
What is the time now exactly? One second. What's the time now exactly?
11:25.
Okay, Let me check once. I'll keep. I'll post you in chat. I'll ping you. Huh?
Sure, sir.
Let me
Sure.
check. Okay. So I'll ping you. So
Okay, sir.
just get ready. So at the time we will see what is the role based access controls and all. Okay. Let us close. We are going too much deep into this
Okay.
Kubernetes. So let us close. We have
Yes, sir.
to do some more. Okay. So fine, Yashant. We'll connect in next whenever. I'll ping you next class. So until then, take care. Bye bye.
Okay, sir. Okay. Okay, sir.